Okay, so I will apologize. I don't have the best setup here. The cable is only this long. I would prefer to sit there and be able to face you guys, but I guess I can only face you.
Why is that?
So, and I do need to be able to write, so I can't just use this computer. All right, so combinational logic. Before we start, textbook easy to find?
Yeah.
Reading was okay? I know it's dense, yes. It's mostly like equations, figures, not so much reading, right? Quiz, I know one person said there was some problem. Did anyone else have any problem with the quiz? Was able to detect your answer?
I think that's the spaces. Yeah.
Okay, so it just had to be exact.
Exactly.
Okay, so I will try and figure out how to make it more flexible without having to just enumerate every single thing. But I guess so there was for the one person that had any trouble, were you able to figure out that space thing? Okay, so for now, let's keep it as this like exact thing, but I will try and look into how to solve that. But at the same time, I can just change these questions to multiple choice. Okay? So I'll try and do that. If that's the solution, that's the solution. Okay. So combinational logic. So you guys read about combinational logic, yes? Review? Okay. All right, so we're going to cover truth tables, two-level logic, product of sum, and sum of products. All right, so here's our first thing. So simple truth table. If there's no symbol indicating what the function is, what is this implied as? It's an and, right? So what are components of our truth table? What do I need to put here?
And B is input.
Okay, so I need inputs, right? And I have A and B, like you said, right? And what do I need to enumerate here?
Binary combinations.
All of the possible combinations in binary. Okay, so there's two binary variables, so 4 possible combinations. And then what else do I need to enumerate here? Yep, outputs. What is my output? What is the name of the output first?
Y.
Y. And it is an AND gate, so I can just go row by row of the truth table, right? And I know what an AND gate does. 0, 0, my result is
0,
0, 1, 1, 0, 1, 1. Right? And this is my truth table. So we all remember this? All good? Okay. So a little bit more complex of an example, yes. But again, same concepts. First thing I need to do is draw this table, right? I have inputs. How many inputs do I have? A, B, C. What's my output? y. Okay. So if you do not know this trick, this is how you can enumerate all of these combinations very quickly. Okay. So do we all know this? But now you do. Yeah,
So-
much faster?
We always put them in that.
Yeah, because this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7. Right? I mean, theoretically, you don't need to put them in this order, but it just makes it helpful to have a standard. Okay, so now that we have all of our combinations, we can again generate this truth table by putting the inputs into our equation and figuring it out. Right? So 0, 0, 0, AC, I get. B naught C. A C naught. 0 or 0 or 0. Yep. Okay, so let's do it again for the next row. AC. B naught C. AC naught.
Zero.
Okay, and then 0 or 1 or 0.
One.
And again, for the next row, AC, B naught C,
Zero.
AC naught. 0 or 0 or 0. Okay, again, AC. For the next row. Yes. B naught C. AC naught. 0 or 0 or 0. Okay, next row. AC. B naught C. And then AC naught. 0 or 0 or 1. Okay, again, AC. B naught C. Yes. AC naught. 0. 1 or 1 or 0. Okay, again, AC for the next one. Yep. B naught C. 0 or 1. I hear 1, any 0. Am I just hearing wrong?
Zero.
Yeah, it's 0. And then AC naught. Yes. And then again, 1, because 0 or 0 is 0, but 0 or 1 is 1. And then for our last row, AC is. So do I even need to think about the other ones? Okay. So we're all refreshed on truth tables. No questions about truth tables?
Please grow for y. Y equals 1 plus 1 plus 0. How do you end up?
Here? This one,
above it,
6. Are you talking about this one?
the one above it,
So you're talking about 5?
yeah. When you did AC plus B, not C plus A, not C, you ended up with 1 plus 1 plus 0.
Okay, so let's just do this again. So AC, we know that 1 and 1, and then B naught C. So B naught, it's 0, so it becomes 1, and C is 1. So 1 and 1 is, and then AC naught. So A is 1, but C is 1, so it becomes a 0. So 1 and 0 is 0. And then the plus symbol, what does the plus symbol mean in the digital logic? It means or, right? So it's just an OR gate. So it's, is this a 1 or is this a 1, right? So either one of them, right? It just becomes 1. And then we do, is this 1 or is this 1? Either one of them is a 1, it becomes 1. So it's 1. Make sense? Okay. Any other question? I give this to you on a quiz, you can do it. I give you the truth table, you can go to the equation. We haven't covered that yet. Yeah, we're gonna do it. All right, so here is your first checkpoint. So I need to open up the survey for you, so do give me one moment here, but you can work on this while I do that. You guys are 301. This is lecture 2. Okay, your code is 963. So the same link as before, just change the numbers from 504 to 963.
website again?
Pollev.com.
And those numbers, 939.
963. Yeah, 963. Okay, do we have anyone still thinking about this on their own? Okay, so we are like right at this threshold that I would normally go on, but I think that's because we're like really too close. It's a good idea to do the peer instruction. So do talk to the people near you. Go over how you got to your answers and then resubmit if your answer is changing. Okay, just as a reminder, if your answer did change, do change your answer. Okay. We have moved more towards the right answer. So let's go over this together. So I'll just show you how I like to do these kinds of questions. So this is sum of products. So we're working with min terms here, right? If you're talking about the language from the textbook. So what I like to look for first is just what's the simplest min term of these? And that is going to be just C or C naught, right? So let's see what the min terms C and C naught cover. So if we look at C naught, it's every other one of these, right? That it covers. Oh, yeah. Well, I mean, where did I mess up? This one is where I messed up, right? So C naught covers all of those. And then C would cover the opposite ones. So it would cover this where our output is not 1. So we can immediately look at the terms that have C, and we don't need to look at them anymore, right? Because it covers part of the output that is not meant to be 1. So then we can look at the other min terms, and because they're the same size, right? They're both 2 variables. We'll just start with the one on the left. So A naught B. So A naught B. So that covers this. So it can't be A naught B, right? And then AB. So that covers this. So that helps us there. And it also covers, where's the other one? It's already covered by C naught. So that is still a viable option. And then what about, so A naught B is already canceled. So we're already left with one choice. So let's just confirm that the last choice covers the rest of it. So AC, so where A is 1 and C is 1, right? And then we again get coverage again here. So it's fine if they double cover, right? Because they're OR gates. So based on this kind of process of elimination, we land on D. So does this make sense to you guys? And then you could always just brute force it too, right? You can just input it to all of them. It just might take you longer. All right, so what is two-level logic? Does anyone know this answer? It's from the reading, right? What is two-level logic? Anyone? This is review, yes? So it consists of these gates, but what does it mean to be two-level? So your longest path to the output is between two logic gates. So what this means is that you're either going to be product of sums or sum of products. So what we worked with before in this example is, if I erase this real quick, we have a sum of products, right? So we have two levels. We first have to take the product, and then we take the sum of those products. And if you drew it out, you would have a bunch of AND gates. And then over here, it would all be connected to this OR gate, right? So that's 1, 2 levels. So product of sums, it's just the opposite. right? So you have a bunch of OR gates. And then you have one AND gate at the end. 1, 2 levels of logic. So we all know what I'm talking about when I say 2-level logic. Okay. So let's work with this example. So this is sum of products. And here is our truth table. And with sum of products, what we want to look at in terms of the output is, when is it 1? Okay. And then we can easily get our sum of product equation out of this by looking at the row where it's 1. And in order for it to be 1 at that row, I need A naught, B naught, C naught. You see, I need them all to be 0, right? So that's one minterm. So the next place I need it to be 1, I need A naught, B, C naught. Next place, I need A, B naught, C. And then the last one is A, B, C. Right? Do you see this? Another way to write this, and this is also in your textbook in the reading, is the summation, right, of minterms. And we can just give the decimal representation of that row. So here, this is row 1, right? 0, 0, 0. Well, row 0, right? So 0, 2, what is this? 5 and 7. 5, 7. Right? So y is equal to this. So this is an implementation of that truth table as 2-level logic. Yes? Is this the most efficient implementation of that equation in 2-level logic? No. So we'll get into that later on. But today, we're just covering this part. But I just want to make sure that we can go from this to this and back and forth, right? And if I write this on your quiz, you understand what this means. Yes? Okay. So this is your next checkpoint. Going from the truth table, what is the sum of products with those minterms? And again, do this on your own first.
This is an exam or for the A naught variables. Are you gonna have an apostrophe or a line over the variable?
Either.
It's the same meaning.
It's the same meaning. Yeah. 963. Yeah. Okay, is anyone still thinking about this? All right, so we are past the threshold this time. Why are you changing your answers? We're below the threshold now. Okay. I think, were you guys just not finished? Or you just? All right, so we're below the threshold now, so do the peer instruction then. We were past the threshold.
Yes, I'm all about That's the setting. That's the setting.
Okay, I think most of you guys are done with your discussion, so let's go over this together, and we are back to past the threshold. So, so I'm gonna do this. There's many ways that you can do this. So, again, we see that these are sum of products. So I'm just gonna look at the ones, and then I'm just gonna write the minterm for those. So this is A naught, B, C naught, right? This is A, B naught, C. This is A, B, C naught. This is A, B, C, right? So I just need the equation that has all four of these, right? So I see A, B, A naught, B, C naught. This one has an extra one, so we can eliminate this. This has A, B, A naught, B, C naught. This one has it. So I can look at the next one. So A, B naught, C, we have it. This is not part of ours, so we can now eliminate this one. And then this is also the same thing, right? So now we just need to check the rest of A, right? So A, B, C naught, here, A, B, C, here. Right, has all four of them. This is our coverage. So it's A. All right, so product of sums. in product of sums, rather than looking at where the output is 1, we're now going to look at where the output is 0. Okay? And then when we write the product of sums, so it's going to be written in minterms, which are sums. So our first 0, we actually do not negate. So if it's 0, we keep it to the same. So A, B, and then since C is 1, we need C naught. Okay? And then if there's no symbol here, it's implied as the AND gate. So the next one, we have A or B naught or C naught. And the next one, we have A naught or BC. And our final one, A naught or B naught or C. We see this? Okay, and then we can again also write this as the large product, which is just a capital Pi. And max terms, which is a capital M instead of a lowercase m. And this is 1, 3, 4, 6. So 1, 3, 4, 6. So do we see this? And basically all we're doing is saying that in order for this to be true, it's not this, and it's not this, and it's not this, and it's not this. Rather than saying it's this, or this, or this, or this. We're just saying it's none of them. Yes? Yeah, because before we were saying that we were going by the ones. So we were saying that it's either this minterm, or it's this minterm, or it's this minterm, or it's this minterm. But with the product of sums, we're saying it's not this one. So invert them all. It's none of them. And it's not this one. So that's why we invert it again. And it's not this one, and it's not this one. So if it's none of these, then it's true. So that's why it's the inverted. So I wouldn't say that it means the result is that, but that's what you're looking at in terms of the row. So like if I wanted to express this in min terms, I would look at the row where the output is 1. And if I'm expressing it in max terms, I'm looking at the rows where it's 0. So the other thing that I wanted to note with that is when you look at the output, if it's more ones than zeros, that means I can express that more efficiently with max terms because I have fewer zeros to look at, right? And then if it's more zeros than ones, I can express it more efficiently with min terms. And the other thing that you can do if, say, you don't like looking at max terms, like to me, this looks ugly, right? I don't know why, but I prefer min terms. And say that it's more efficient to do max terms. You could just simply invert your output, do it as min terms, and then invert it at the end. And now you can only work with min terms if that's what you prefer, or you can only work with max terms if that's what you prefer. Okay. So last thing today is the max terms question. So again, answer on your own first. So I think most of you guys are done. And if you're not, in the interest of time, we are not quite at the threshold, so do talk to the people around you. And it's okay if you're not done, you can work through it together.
No, I don't know. You make mistakes on the speed. The very last part of the data, you're not really big on it.
I mean,
So it's like, oh no. I was like, so you didn't make a mistake. I was all looking at that. You're like, you made a mistake.
I think you made a mistake.
okay, I think we are done discussing. And you guys have moved past the threshold. So again, we can just do this the same way. So first we need to see the 0 max term. So this one has it. And that's it, right? So now let's see if it has 1. So this is 1. Does it have 3? Yes, this is 3. And then does it have 4? So this is not 4, right? That's 5. So we eliminated this one first, and then we eliminated this one, so the last option is E. Right? Okay, so before I let you go, I do want to ask you, so has anyone tried to do this? Okay, keep your hands up. If you were unsuccessful in doing this, put your hand down.
Successful.
Yeah, but I mean, it's a lot. It takes 200 gigs.
Fucking math.
Yeah, but once it's installed, it's only 50-ish.
I didn't see
There's no video instructions. It's just the link, and then the PDF instructions. Yeah. Okay. Okay, so if you have not done this, which seems like the majority of you, do try to do this, because later on, you will most definitely need to work on the labs outside of the lab. We do have open lab hours to support that if you need to use the lab computers. But it's more flexible if you have your own. And you can check out the boards. Okay?
That final slide, that is the version you want.
It's not super important about which version.
Because there's 2 different softwares and they each have a different years.
So the more important thing is that you're installing Design Suite with the HLS, because one of the labs requires this. Okay, so I don't think there's a reading. Is there a reading?
For next week, we get
Justin,
Uh-huh.
there's 3 versions listed on the website. Is it-
You want Vivado Design Suite?
Okay.
Vivado.
It's on your slide, it's in the 22.0 or something like that, but on the website.
Yeah, the version is not super important. What's important is that you have the right software. Yeah. Okay, so I am closing the poll. So make sure that you answer